Okay, so they're giving us this equation, 8y equals x squared. And they want us to find the focus, directrix, vertex, and graph the thing. Okay, so how are we gonna do it? Well, let me go to the notes with you, because that's gonna be the most helpful place to get this kind of stuff. So here it is, here's the 4 directions, and then one more page we need. And there's like the steps, okay. All right, so yeah, so first step is to get x or y squared alone and then factor out 4 or negative 4 from the other side. This is from the notes, telling you how to graph parabolas. Okay, so first step, get x or y squared alone, it already is, and factor out a 4 from the other side. Oh, okay, so this will be 4 times 2y. At least in my case, you're going to have different numbers. So that makes sense. 8, I factored out a 4. We're always pulling out a 4. Why? Not because we care about the 4, but because we care about the number that appears next to the 4. Does that make sense? So it's always about the number that appears next to the 4. That ends up being called A, and that ends up being super important to us. We find almost everything using that A. So the first step, whenever you're dealing with a parabola, is to get the x squared or y squared alone, it already was, and then factor a 4 out of the other side. And then grab that number that appears next to the 4. That's your A. And that'll be super important.
So if
I haven't changed anything, right? I've done what I like to call plastic surgery. I removed the wrinkles. We've given a new look to the equation, but it's the same equation it was before. 4 times 2 is still 8y. That's still 8y on the left side. It just looks different now, right? Why do we do that? Well, because we really need to grab that number next to the 4. That really helps us graph. That's why we do the plastic surgery we do so often in mathematics, because we need to make the equation look a certain way so we can get the stuff we need to do what we need to do. In this case, we need the number next to 4 because that's A and that helps us. Okay, so that's one.
If 8 was negative, would you just take a negative 4 out? And would
exactly. Yeah, that's right. Yeah, exactly. So if this was negative 8y, I would just, in fact, let's do that. That'll make it more fun. It'll be more fun. I like your idea. I would just totally take out negative 4. A would still just be 2.
Okay.
Exactly right. Good job. You've got it. Thanks for that clarification. Yeah, coming on down. Factor out 4 or negative 4. Yeah, by that, I mean exactly what you're saying. If it's negative, take out negative. If it's positive, do positive. Exactly. So let's just change it. Let's say it was, let's pretend the problem said negative 8y. That'll make it more interesting anyway. Take out a negative 4. A is still just 2 though, right? Regular 2. Okay. So now what of it? Well, now, next we got to figure out which way is the thing going to go, right, left, up, or down. How do we know? Well, as this says, and I think I might add to the notes a little bit more clarity, but basically says it's all about the positive or negative first power letter. So what do you mean first power letter? What I mean is notice how parabola we have x squared on one side and y to the first on the other. Parabola is the only one of the ones we're looking at that has one of the letters is a second power, the other is just a first power. Remember, for the ellipse and the hyperbola, they were both second power. X was second power and y was second power. But for the parabola, one of the letters is second power, but the other is just regular first power. Well, that one's the key. That's the unique mark of the parabola, and that one's the key to telling you the direction. So what does it say? Negative y. Where's the negative y direction? Well, that's down. You know the negative y direction. This parabola is going down. Does that make sense? Negative 4 times 2y. Negative y is down, isn't it? This parabola's got the branches are going to go down like that, aren't they? It's got to, because the negative y is down. So, and that's what we see right here. Ours looks like this, doesn't it? Now you might say, yeah, but our x squared's on the right side. Remember, right side, left side doesn't matter at all, right? If two things are equal, it doesn't matter which one you say first. If I say, Mary's age equals Johnny's age, or I say Johnny's age equals Mary's age, it's the same statement. It doesn't matter which one I say left or right. right? This equals that. Doesn't matter if you say x squared. So that's why we can't fixate on left side, right side. They can change that up on us as they are on this very problem. So don't fixate on left side, right side. That's not reliable. What is reliable is first power letter or second power letter. It's always the first power letter. First power opens down, parabola branch down, which means the focus point is in. It's always inside the branches. So when it goes down, it'll be down in there. If the parabola went up, focus point would be inside up. If the parabola went to the left, the focus is inside left. The parabola went to the right, focus is inside right. So the focus point is always inside the branches, whichever way they go. So in our case, the branches are going down, the focus point is down. So the focus point is down. Down how far? A, whatever A is, that's why A is so important. 2. So right there. There is the focus. And what's the coordinate set? Over 0, down 2. That's going to be, I'll put a little, I don't know where to, it's not enough room. Yeah, let's put it right here. That's the focus point. And I'm going to write his coordinates right here. Over 0, down 2. There it is. What's the directrix line? Same direction, other side. Back 2. It and so where am I getting that? Just look at this picture here. Here's whoops. Here's ours. We're going down. Right? We're going down. Focus point is inside. Directrix line is behind it. Always. See, even if it was going up, focus point inside, directrix line behind it. See all these graphs? If it's going left, focus point inside, directrix line behind it. If it's going right, focus point inside, directrix line behind it. And as it says right here in the note, the directrix line is always behind the branches. Again, there's that a distance A for the center. Same distance as the focus, just the other way. That's why that A is so important, which is that number that is next to 4 when we factored out the 4 in the first step. So we go, oh, okay. So getting back to this graph, the center, oh, and I forgot to put the center on, huh? Center is right here. This is the vertex or center at 0, 0. So I could have filled that in right in the beginning. That's 0, 0. That's the center. Vertex just stands for center. So the center is 0, 0. The branches are going to go down, as we know, because it's negative y to the first power. And the directrix line is back to, just like the focus is down to, the directrix line is back to. Now, the directrix line is a line. It's not a point, so we need the equation of the line. What's the equation of that line? Well, does it go through the x-axis or the y-axis? It hits the y-axis at up to y equals 2, doesn't it? See how that directrix line goes through the y-axis at up to. So there it is. So now all we need, good question, Tim. For now, the center is 0, 0. We're going to be getting to problems pretty soon where the center is not 0, 0. How you know is they'll put a number next to x or y. In a little bit, we'll see equations like this. They'll have x plus 3 squared, and this will be minus 4 times 2, y plus 7. And we'll go, oh, that 7 and that 3, that's the new center. It's actually opposite. It'd be negative 3, negative 7. So that'll be in a little bit. So if they don't have any number, added or subtracted next to x and y, then the center is 0, 0. Good question. Center, the center, called the vertex, is 0, 0 when there's no numbers added or subtracted next to x or y. Does that make sense? You might say, well, there's numbers next to x and y. There's numbers there. Yeah, but they're not added or subtracted. That minus 4 and that 2, or back here, minus 8, same thing, are multiplied, by the way. That doesn't move the center. So if all you have is numbers multiplied by x or by y, the center is going to be 0, 0. The only thing that makes the center move is when you have numbers added or subtracted next to x or y. That's coming soon. Coming soon to a classroom near you. But for now, this one, no numbers added or subtracted next to x or y. Good question. The center is 0, 0. All right. Now, we're almost done, right? We've got it's all, again, first step, factor out the 4 or negative 4. And grab that number next to the 4 or negative 4. That's super important. That tells you how far from the center down to the focus, down to How do we know it went down? Because it was negative y on the right side. The branches have to go down. Negative y direction. I shouldn't say right side. Negative y on the first power side, whether that's left or right, whatever, doesn't matter. It's the first power letter side. It's negative y down, and the vertex line is back to that A again, telling us how far to the focus to, how far back to the directrix to. Now, last thing is we need to know, how do you make these branches? Are they like really narrow? Are they like super wide? Are they somewhere in between? How do we know? We need some dot, don't we? We know it goes from the center, but we need like some other dot out here to make it. How do we get that dot? Well, that's where I'm telling you right here in the notes. I'm telling you 2 points. On the branches called lattice rectum points are plus or minus A or plus or minus 2A, like this. Specific, see the pictures. They are always at the focal depth inside the branches, but twice the focal distance away from the focus. So notice you can see them, like see the 2A, 2A. Which one are we're on? We're on this one that goes down. So ours are going to be 2A negative A and negative 2A negative A. But anyway, I wouldn't memorize it that way. I would just take a look. It's at the focal depth, twice the distance. That's what it's saying. So in other words, I say, okay, it's going to be, the branches are going to come down like this. Here's the focal depth. You go to the focus and you double that distance to the side. What do you mean double? It's 2 here, double that, 4. 1, 2, 3, 4. There's one of them. 1, 2, 3, 4. There's the other. There's the 2 points it's going to actually hit. See how I'm finding that? You go, how far is it to the focus? 2, double it, 4 each way. Now, what if it was like 3 to the focus? If it was 3, I would double that, and it would be 6 and 6. If it was 4 to the focus, I would double it, 8 and 8. If it was 5 to the focus, I would double it, 10 and 10. Is that making sense? However far it is to the focus. That's A, by the way, right? Double that, and that's how far you go out to the lattice rectum points. And it's at the focal depth, right? So if the focus is down at 5, then from the focus, go 10, 10. Our focus is at 2. So from the focus, go 4, 4. So there we go. So right here, boom, and right here, boom. See how I went? Back 4. And right 4. At the focus point, double the focal depth. So there it is. That's a point. So when you make the graph, it'll go through that point. Oops, that was not so good. I'm going to use my tool, make it better. And that point, like that. Is that making sense? It has to go through those points. So, so there we go. So one more time, let me recap, and then let me show you the actual tool online, how it works. So one more time. When you have no numbers added next to X or Y, that makes your center 0, 0. That's called the vertex or the center. And then you've got to factor out a 4 or negative 4 on the first power letter side. And then that tells you up, down, right, or left. The first power letter says negative Y, down. These branches are going down. The A tells you how far down. How far down to the focus? 2, that's A. And how far back to the directrix? 2, from the center, that is. And then you double that. At the focus, you go, it was 2 down, you double it, 4, 4, to get the 2 points on the parabola, called lattice rectum. Connect those, you got your graph. So let me show you how it actually works on the actual tool, because that's a little bit tricky too. So switching over to the actual tool, I'm going to go to the problem, 8.3, the parabola. All right, so it made up a different one for me. And mine is 12y. I wonder if I could get a negative one. Let me try to get a negative. Yeah, you could, negative 12y. There we go. So there's negative 12y. So I'm going to first off say, well, here, I'll just show you. There's the focus. There's the directrix. There's the vertex. 0, 0. For the vertex centered at 0, 0. The focus is down because you'd factor out a negative 4 from this, and that would leave a 3 next to that, right? It's going down. All right, so let me show you how to get the graph. That's what I really wanted to show you here. So I'm going to go center 0, 0, and then I'm going to grab a lattice rectum point. How far is it going to be? Well, if it's 3 on this one to the focus, it's going to be double that, 6 to get to the lattice rectum. So here we go. I'm going to click on the parabola tool. See these different tools here? Sideways parabola, vertical parabola. I'm trying to do a vertical parabola. It's going down. So I'm going to click on the center. See the little tool, how it has a dot on the center and then one other red dot on the center and then one other red dot. Means it wants you to click on those two things. Click on the center. Now, as I move out, it's trying to make a parabola up or down. Where am I going? Well, look up here over, oh, I got to go to the focus. So remember the focus is down 3 right here, which I'll put that on in a minute. But then you got to go double that. So that means over 6. Click. I'm going to click right there. Does everybody see how I'm finding that? Because on this one that's on the screen right now, get my back up here. See, the focus is at 0, -3. So I went from the center, I clicked on the center, went -3, went to the focus. That's going to be the focus, which I will put on in a minute. And then you double that. So if it's 3 to the focus, double that, be 6. Click. Now I could have gone -6, same thing. That'd work too. Click. See, it's already got that same point. And now you've got to put now click this little dot maker and put the focus point. Bonk, right there. See, I just put the focus on. And then click the line maker and go 3 back and click any 2 places on that line. Boom. And make the line. That's the directrix line. See what I did there? I made the directrix line go through the y-axis at 3, made the focal point over 0, down 3, and then I made this parabola, and I went down 3, double that over 6. There it is. If I submit that, it's green check mark. It's right. That's all the stuff it wants you to do. You got to make all those on the graph like that. So there we go. Let me switch back over to the iPad. And so there you go. For mine, the distance was 2. So center 0, 0, down 2 to the focus, back 2 to the directrix. How do we know it went down 2? First power letter was -y. Then I doubled that 4 and 4 to the lattice rectum points. There we go.